So this lesson we learn about something called the law of sines, and the idea deals with solving a triangle, which is something we've done before but only with right triangles. We're going to look at oblique triangles, and an oblique triangle is a triangle that doesn't have a right angle. So if we want to solve an oblique triangle, which that means is that we want to find any remaining sides or angles that we don't know, we need some information to start with. At least we need to be given one side and then two other parts to the triangle. And if we're given one side and two other parts, whether that's two other sides, two other angles, an angle and a side, we can solve the triangle, and that means is find the remaining pieces. So if I had some random triangle that wasn't a right triangle, let's say something like this. There are three angles and three sides, so 6 parts altogether. If we call this angle, say angle A, this angle, angle B, and this angle, angle C, typically what you'll see is capital letters used for the angles. And then the sides we label with the same letters, just lowercase. In that case, the side opposite of B, we're going to use the same letter, and this side will be lowercase b. This side here would be lowercase a, and this side here would be lowercase c. So I got 3 sides, 3 angles. What you may also see is that instead of angle A, B, C with capital letters, they would use alpha, beta, and theta as the angles using the Greek letters alpha, beta, and theta. And then still A, B, and C for the sides. Opposite alpha is A, opposite beta is B, and opposite theta is C. So it all depends on sort of what you're doing, what book you're using. Our book uses alpha, beta, theta. I like ABC better, but it doesn't matter. Anyway, so we have this oblique triangle, and in this oblique triangle, let me get rid of the black writing. Alright, so you can see this, the arrows. Alright, so we're looking at this triangle, and you're going to have to be giving something to find the remaining pieces. Now there's 6 parts altogether. You're given 3, you have to find the other 3. And out of the 3 you're given, at least one of those pieces has to be a side, and then 2 other parts. So I could be given this side, and this side. In that case we call that side, side, side is what's given. And we could solve the triangle basically finding the remaining pieces, in that case all 3 angles based off of that information. I could be given this side, this angle, and this side. In that case we call that side, angle, side. So that would be this situation, side, angle, side, where the angle is in between the 2 sides. But I also could be given, say, this side, and then this angle. In that case we would label that side, side, angle. And you could say angle, side, side, or side, side, angle. It doesn't matter whether you go this way or you go this way. It's 2 sides that are together and an angle after or before. So that would be this situation here. And then another possibility is, this is starting to get kind of messy, but let's try one more. You're given this side, and you're given, say, 2 other angles. So it would be angle, angle, side. Okay? Or we could do angle, side, angle. Okay, with this angle, this side, this angle. But 2 angles and a side, and again, there's 2 ways to do that. Angle, side, angle, where the side is in between the 2 angles, or angle, angle, side, where the 2 angles come and then the side after that. So, you know, again, if I did angle, angle, side, if those were the information given, I find the remaining pieces. So these are the different ways you can be given a side and 2 other parts, and then we would have to find the remaining pieces. Now, which information given really affects the way you solve the triangle. And again, this is just for non-right triangles. If it's a right triangle, we'll use all our old stuff we did in the beginning of trigonometry to solve a right triangle. These are for non-right triangles. So the idea is if you're given something in these first 2 groups, where it's 2 angles and a side in any way, that's these 2, or 2 sides and an angle where it's set up specifically where the sides are next to one another and the angle's not in between, This is where we use something called the law of sines. However, if we're given one of these other two here, side, angle, side, in that case it's still two sides in an angle just like this one is, but it's two sides where the angle is in between, or three sides consecutively. This is where we're going to use something called the law of cosines. Now for this lesson we're only going to focus on the law of sines, so these two. The next lesson we'll focus on these two. So if we're looking at the law of sines, the law of sines is a set of equations in that really it's a proportion. And a proportion is when you have a fraction equal to a fraction. Well, what we have here is really three fractions equal to one another. And the fractions are based off of the sides and the angles. So it's a ratio of the sides and the angles to create this law of sines. So these formulas right here are the law of sines. They're really the same equations. You can call this the law of sines or this. The difference is whether we want the sides on the top, because that's a lowercase letter of the sides, or we want the angles on top. So it's a over sine A, b over sine B, c over sine C. Whenever you have a bunch of fractions equal to one another, if you flip all of them over, then it's still equal. So here we just did sine A over A, sine B over B, sine C over C. So this set of proportions is what we call the law of sines. And these proportions allow us to plug in what we know and solve what we don't know, and essentially find the remaining pieces that we don't know. Now there's really two cases for a law of sines, whether you have option 1 or option 2. If you have option 1, where you have two angles and a side, it's very straightforward. You use these formulas as you see them and you get your answer. However, if you have the second option where you have two sides and an angle and the angle is not in between, so side, side, angle, law of sines can get a little bit tricky. So we're going to look at both situations. First we'll look at the easy one, this first situation, where you have two angles and a side in any order. So here's a situation where we have the basic two angles and a side, either angle, angle, side, or angle, side, angle, and we resolve for the remaining parts. Again, this is the most straightforward type of law of sines questions. So here's a problem. It's giving you this information. Given A is 123 degrees, B is 41 degrees, and side A is 10, find side C. So what I would suggest you do first is to draw some random triangle. It doesn't have to be drawn to scale accurately. Just draw a random oblique triangle. Label your angles. It doesn't matter how you do that. A, B, C. Now how I label my angles affects the way I label my sides. That's the only important part here. If I label this A, B, C, then this has to be side A, side B, side C. And then from there I go, okay, well they told me that A was 123 degrees, B was 41 degrees, we don't know angle C, and we do know side A is 10 inches. So now we need to find the remaining parts. Well, the only part they really tell us to find is side C. So this is the side that we're looking to find. Unfortunately, we can't go directly and find that side. The key to these proportions that create the law of sines is you have to know a certain amount of variables to be able to solve a proportion. A proportion has four parts to it. Two numerators, two denominators. And out of those four parts, in order to solve a proportion, you have to know 3 out of the 4. So if you look at this, what do we know? We know angle A, side A, and angle B. So if I set up the proportion that I do A over sine A equals B over sine B, there are 4 parts to this, 2 numerators, 2 denominators. I know this piece, and this piece. I don't know B, so I can use this proportion to help me find B. And once I find B, I could get this value. Now, that's not really what we're looking for, right? What we're looking for is C. But I can use that same idea. Well, if I think about it in terms of, say, C, I could do A over sine A equals C over sine C. But I don't know 3 out of the 4 of these, right? I know A, angle, and side. I don't know angle or side C. So if I'm going to try and solve this proportion and find C, I need to know angle C first before I can find side C. But once I know angle C, I can do that. So if I'm looking at doing these problems, I need to know 3 out of 4 parts to any one of these proportions. So the first thing I'm going to have to do is first find angle C. Well, that's going to use a little geometry. The sum of the angles inside a triangle equals 180 degrees. So that means 123 plus 41 plus C has to be 180 degrees. So then I can figure out what C equals. Do 180 minus 123 minus 41. I come up with 16 degrees. Okay. So now we know that angle C is 16 degrees. Well, if we know angle C is 16 degrees, now we know our third part. And we can use this proportion to help us find side C. So what we get is that angle A is 123, so this is the sine of 123. And angle C is 16, so this is the sine of 16. Side A is 10 inches, and we don't know side C. So now it's just an equation where I have to solve for this variable C. What I'm going to do is I'm going to take this piece and multiply it to the other side. I get 10 times the sine of 16 over the sine of 123 equals C. Plug that into your calculator, and you got your answer. Make sure your calculator is set to degrees because that's what these are. So I do the sine of 16 degrees, sine of 123 degrees. But that's going to get you your answer for what the measurement for C is. The solving part's not bad. It's setting it up that you got to make sure you do. So I come up with an answer of 3.3, and this would be in inches. So this side here is 3.3 inches. Now what you want is to make sense of this answer. If this angle right here is the biggest angle, and we found out that this angle was 16 degrees, then this side should be the biggest side. So proportionally, this angle and this side should work out very similarly. This is the smallest angle, and this side is smaller than this side. So if this angle's smaller, then this side should be smaller, and it should make sense. Like, if I got C to be, I don't know, 22 inches, I would know right away that that is wrong. There is no way that this side could be 22 inches if this angle's 16, but this angle's 123, and I get 10 over here. So make sure you look at your answers and say, does this answer make sense? And 3.3 does make sense proportionately within this triangle. So that helps me solve for C. So this is law of sines. We could then use law of sines to find the last piece, right? The only thing that's missing is B, side B. We found angle C, we found side C. They already had angle A, angle B, and side A. So we could do law of sines again with this equation and find angle B. The best way to set up law of sines, because you have two different ways to do it, where you put your sides on top or whether you put your angles on top, like this, is to think about what are you looking for. If you're looking for an angle, put your angles on top. If you're looking for a side, put your sides on top. It's just easier to solve. Whichever variable you're trying to solve for should be in the numerator of the fraction. So that's a nice little trick to help you with these two. So here's another one. A triangular plot of land has interior angles 95 degrees, 68 degrees. If the side between these angles is 115 yards long, what are the lengths of the other two sides? So I'm just going to draw a random triangle. I'm going to label this A, B, C, A, B, C. So if this is 95 degrees, this one is 68 degrees, and the side between them, which would have to be B, is 115 yards. What are the lengths of the other two sides? What are the lengths of this side and this side? So we need A and C. Now look at what's given here. We're given an angle, a side, and then another angle. So two angles and a side. and the side is in between, so it's an angle-side angle situation. That is a law of sines problem. If we go back to the last one, I didn't note this, but let's go back to the last one. We were given angle, angle, and a side. In that case, it was this angle, and this side. So that problem was angle, angle, side. Two angles and a side in any way, shape, or form, two angles and a side, is a law of sines problem. That's when you apply the law of sines formula. There will be different formulas depending on what is given. So that's going to be fairly important to notice. So law of sines for two angles and a side, whether it's angle, angle, side, or angle, side, angle. Alright, so now we got to set up our proportions. What do we know? What don't we know? Well, we don't have any pairs of anything. We don't have an A and an A, a B and a B, or a C and a C. But what I can do first is find angle B. Again, 180. 95 plus 68 plus B equals 180. So I can get B to be 180 minus 95 minus 6. So I come up with 17 degrees. Now we got a pair, B and B. So I'm going to go B over sine B equals, let's start with A over sine A. So I know B is 115 and angle B is 17 degrees. And I don't know side A, but I know angle A is 95. So I go 95 degrees. Solve for A, I get 115 times the sine of 95 over the sine of 17 gives me my A. Plug that in your calculator, and it's really important to use a calculator for all these. There's no way you'll be able to do any of these problems without a calculator. So make sure your calculator is set to degrees. You plug this into your calculator and you get A. So I come up with 391.8. And this would be in yards. Rounding, I'm not going to be too concerned with the way you round. 1 decimal place, no decimal place, somewhere around there would be fine. I mean, the answers you're going to have for the quizzes are going to be multiple choice, so whatever it is on the test, 1 decimal place, 0, just go with that. Alright, so then we want to find side C. So side C, we're going to basically have the same setup. We're going to go B over B again, because that's what we know. And we're going to go C over sine C. So this is still 115 over sine 17 degrees equals C over sine of, where are we at here? C is 68. So I get 115 times the sine of 68 over sine of 17 equals C. This is all degrees. Plug it into your calculator and you get, I came up with 364.7 yards. So this one is 391.8 yards and this one is 364.7 yards. Now, is that correct? Well, I mean, there's no guarantee. I mean, I feel pretty good about it as long as I plugged in my calculator right. But you can just check to see if it looks right in that what are the angles and what are the sides, and are they all proportionate to one another? We found out that B was 17, right? This angle right here is 17 degrees. That's the smallest angle, so this should be the smallest side. It is. This is the next smallest angle, so this should be the next smallest side. It is. This is the biggest angle, so this should be the biggest side. It is. These two angles are fairly close to one another. These two side measurements are fairly close to one another. That makes sense. This one's pretty far off. This side length is pretty far off. So proportionately, it looks right. So these are the values that I need for my sides. So we saw that two angles in a side in any way, shape, or form is law of sines, and it's pretty straightforward. You apply the formulas, you get your answer. Now, two sides in an angle is another way of calculating a triangle. However, the way the two sides in the angle are given makes a huge difference. Whether you're given side, side angle, or side angle side, that's both two sides in an angle. Here the two sides are next to one another and the angle is either before or after, because this would be the same thing. Obviously there are reasons why we don't write it that way, but the idea is it's two sides next to one another and an angle either after or before. This is very different. It's two sides and the angle is in between. So it would be a triangle where you have this side, and this angle, you know. This is not law of sines. We cannot apply law of sines to this situation. That situation would be law of cosines. But this situation is a law of sines problem. However, it's a ambiguous case of law of sines in that it's a little bit trickier. When we did the two angles in the side, we applied the formulas, we got an answer, we were done. That's not as simple as this one though. This one, there's a couple of things that can happen. You could result in multiple answers for this particular problem. You could have one triangle that fits these characteristics. You could have no triangle at all that exists that fits these characteristics. Or you could have two different triangles completely that fit these characteristics because of what's given and how they're given. Determining what you have is the most important part. Do I have one triangle, two triangles, or no triangles that could possibly exist given the information I have? And even before that is realizing that this is a law of sines situation is important as well. So it can get kind of tricky. So we need to look at how do we determine what kind of triangle we have, or how many triangles we have. So let me erase some of this. Alright, so what we have here is this ambiguous case. First of all, we're going to label what's given as angle 1, side 2. And it's going to be given in this order where we have an angle, then a side, then a side. So the angle 1 is the only angle that's given. The side that touches that angle, which is here, we're going to call side 1. The side opposite the angle, we're going to call side 2. Now, if side 2 is bigger than side 1, there's no ambiguous case. You have one triangle. You're back to basically the problems like we just did. You apply the formulas, you get an answer, and you're done. What happens though is if side 1 is bigger than side 2, then we have to worry about a couple of things. Next, if side 1 is bigger than side 2, is A1 acute? A1 has to be an acute angle. Acute angle means less than 90 degrees. Now, if that all sets up, we have the ambiguous case. The ambiguous case says that we could have 0, 1, or 2 triangles. That all depends on another value which we're going to determine as h. H is a distance. And h is the distance if I dropped a line from this angle here, which we don't know what this angle is. If I dropped a line from this angle here down to this side, which we also don't know what it is. That's why I put a dotted line here. This side could be as long or as short as we need it to be to create a triangle. But if I drop a line straight down so that this is perpendicular, so it's 90 degrees, the distance of that side we're going to call h. And since this is perpendicular in a right triangle, what I have, if I blow this picture up, is that this is A1, this is side 1, this is 90 degrees, this is h. We have no idea what that side is, or we have no idea what that angle is either. But through trigonometry, we could calculate h. Think about it, right triangle, this is my angle, this is the opposite side, this is the hypotenuse. So opposite over hypotenuse is sine. So I'd say the sine of A1 equals opposite over hypotenuse. Or side 1 times the sine of A1 equals h. So I can calculate h using this formula. So here's my formula to calculate h. knowing that side 1 is the side that touches the angle given. Once I figure out what h is, I need to compare it to side 2. If h is smaller than side 2, I have 2 triangles. If h is equal to side 2, I have 1 triangle. And if h is bigger than side 2, no triangle would possibly exist with these measurements. And the idea kind of goes like this. If I give you sort of the short version of it to get you through here. Erase, 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 erase. The idea is this. Let's say I have this picture where I know this side length is fixed, okay? And I have this side length here. And I have this angle here is given. But I don't know how long this side needs to be because it wasn't given as a value. Well, let's say I have this angle fixed. And say this angle is, I don't know, 88 degrees. So it's a fairly big angle. And this side here is, I don't know, 10 inches. But this side here is only 1 inch. Do you think, even though I don't know what this angle is, I have no idea, and it could be anything, which means I could swing this leg back and forth this way, do you think there would ever possibly be a way, if I can make this side as long as I want, and I can make this angle as big as I want, that I can make this leg attached to here so that I can make a triangle? And the answer is no. Because this angle is too big and this side length is too short, I can't get a triangle to happen with these particular measurements. So because of that, I get no triangle. Now, if another possibility is that, this distance here, which is my height, compared to this side, if they're equal, that means this side and this height are the same thing, which gives me this right triangle. So I get that situation, which is one triangle. And then the third situation here is that, alright, well, S2 is bigger. Well, if S2 is bigger, that's this side, is bigger than H, bigger than this distance, then the idea is I can get this triangle to happen, which would be this one, but I could also swing this leg here back this way, and it would still be bigger than H, and I would get this weird triangle that looks like this in here, which is another triangle that has the same measurements, A1, S1, S2, but different from this triangle. So that's kind of the idea of what happens, and if it's not completely clear in terms of the picture, I understand. But what you need to do is understand, how do I calculate which situation I have? And the way you do that is first to compare side 1 and side 2. Side 2 bigger, 1 triangle, don't worry about any of this, go and do law of sines. Side 1 bigger, then you worry about this. Calculate H using this formula. If H is bigger, smaller, or equal to side 2, it tells you which situation you have. If you have no triangles exist, you don't have to do anything. Because no triangles exist, you don't have to apply any formula. The problem can't be solved. If one triangle exists, you apply law of sines, just like we've been doing in the past 2 examples. You get your answer and you're done. Now, if 2 triangles exist, you're going to apply law of sines, get an answer, but then you're going to have to somehow come up with a second answer. And we'll see how that happens. So let's see a couple of examples of these situations. So here we go. Given A, B, A, find the other side into 2 angles. So draw a random triangle. Look at what's given. Think about what we have. A, B, C, A, B, C. 21, 5, 26. Okay? So we're given angle, side, side. Angle, side, side. Or you could say side, side, angle if I read it this way. Okay? But the idea is, this is that possible ambiguous case. So what I need to do is label my sides and my angles. This is angle 1. The side that touches that angle, which is this one, is side 1. The side opposite that angle is side 2. So the first thing I do is I got to compare side 1 and side 2. In this case, side 2 is bigger. If side 2 is bigger, go back to my last slide here so you see it. If side 2 is bigger, you got one triangle, you skip the ambiguous case, and you go and do law of sines. So that's what we're going to do in this problem. It's basically the same as the last two we did. So if I want to calculate the remaining pieces, I'm going to use the fact that I have sine A over A equals, we'll use B, so sine B over B. I know angle A, side A, and side B. I need to find angle B. So what I'm going to do is say sine of 26 over 21 equals sine of B over 5. If I multiply by 5, I get 5 times the sine of 26 equals over 21 equals sine of B. Now here's a problem. I need to know what B is, not what sine of B is. B is, so I got to get rid of this sine. I can do that very easily. Get rid of the sine here by doing an arc sine on the other side. And now I know what B is. So now you got to plug that into your calculator and you get angle B to be, I get 5.99, so we'll say 6. Alright, so that's one angle down. So now we need to get the next angle. Well, if we know A and B, we can get C, right? So we got A is 26, B was 6, so that tells us that plus C gives us 180. So C equals 180 minus 26 minus 6. So I get 148 degrees for my C. So this is 148. This is 6. So then I find side C is the last thing I need to find. So I got angle C, I got angle B. I need to know side C. So I can use anything here. I'm going to use that A over sine A equals C over sine C. So I'm going to say 21 over sine 26 equals C over sine of 148. So multiply, I get C to be I get 25.4. If you said 25, that wouldn't be a big deal. And is anything calculated? Yeah, feet. So we're calculating in feet. So C is 25.4 feet. Angle C is 148 degrees. And angle B is 6 degrees. So that finishes off the triangle. But that was an easy one because there was no ambiguous case. So let's look at another one where there's an ambiguous case. So here's another one. Alright. B, C, B again. Find angle C. So let's look at this here. Triangle. A, B, C, A, B, C. So we said B was 78 degrees. Side C was 12. Side B was 5. So what was given? Angle, side, side. So two sides and an angle, not in between. That's that ambiguous case situation. This is law of sines. Okay? So, we need to figure out what do we have. We'll label our sides. Angle is always angle 1. The side that touches that angle is always side 1. And the side that's opposite that angle is side 2. So compare side 2 and side 1. Which one's bigger? Side 1 is clearly bigger. That's the ambiguous case. Now I have to find H. Well, H is calculated by side 1 times the sine of angle 1. So in this case, it's going to be 12 times the sine of 78 degrees. And that'll tell me what h equals. So I come up with 11.7 as my h value. So now what you have to do is compare h and side 2. Well, if this is side 2 and this is h, which one's bigger? Clearly h. If h is bigger, go back to my chart I gave you. Let's erase some of this so you see it. If h is bigger, no triangles exist. So if I look at this, since this happens, I can't find angle C. It doesn't exist. So I'd say no triangles exists. I can't find angle C. Now, something like that. I mean, just basically saying you can't do it. There's no answer. So that can happen. That's a possibility. Alright, let's look at one more. Given A is 29, A is 6, B is 10, find B. Now, really, I should say, if possible. Right? Because we just saw that it might not even be possible to find B. So draw your triangle. A, B, C, A, B, C. So we go 29, 6, and 10. So again, what was given? Angle, side, side. So two sides and an angle, that's your law of sines. Okay? Also the ambiguous case law of sines. Side 1 is here, side 2 is here. So if I look at side 2 versus side 1, side 1 is bigger. That's the ambiguous case. Now I have to find h. So h is calculated by side 1 times the sine of angle 1, which in this case is 10 times the sine of 29. So I plug that in my calculator. I come up with 4.8. So if I compare 4.8 to side 2, I find out that side 2 is bigger than h. If side 2 is bigger than h, if you follow my chart again, where are we going to go back to here? Side 2 is bigger than h, you have two triangles. Now, where those two triangles come from is what we need to learn about. But first, let's just find one of them. How do you find one of them? Well, you find the one value that you're going to get for angle B. Well, just use law of sines like we've been using and you'll get an answer for B. That's one of the answers. The trick is, where does the other answer come from? But first, let's just find one of them. So what do we know? We know that A and B. So let's go with sine of A over A equals sine of B over B. Because we know angle A, side A, and side B. We know 3 of the 4, so this will be a good formula to use. The thing we don't know we're putting on top. So we end up with sine of 29 over 6 equals the sine of B over 10. So that gives me 10 times the sine of 29 over 6 equals sine of B. Again, that's sine of B. We just know B, so we got to get rid of this sine. We do that by doing an inverse sine on this side. So if I take the inverse sine of this, that can give me B. So I get B to B, 54 degrees. So that's B. So that's my one answer for B. But there's another answer I can have for B. Now, how does that answer come about? Well, it has to do with this step right here. You're doing the inverse sine. And if you remember when we did inverses, if I take the inverse sine of some value, I don't know, I'll call it y, I'm going to get some angle. The idea is that this is the y coordinate for this particular angle on the unit circle. That's kind of how we read it. So what we did is we said, alright, well, let's look at our unit circle. Here's a unit circle. Here's, I don't know, pi fourths. If that's pi fourths, this angle has a point to be square root of 2 over 2 comma square root of 2 over 2. So if I took the inverse sine of square root of 2 over 2, the answer is pi fourths. That's how inverses work. So I'm going backwards from the unit circle. I have the y coordinate. I'm getting the angle. Okay. The problem is, if I'm looking at this y coordinate, there are multiple angles that have that same y coordinate, specifically one right here. This y coordinate right here is also square root of 2 over 2. And I can't have two answers for the inverse sine of some value. I can only get one answer. This has to be a one-to-one function. So what we said is that all the answers for inverse sine have to be either in the first quadrant or the fourth quadrant, between 0 and pi halves or 0 and minus pi halves, which excludes this value, which means this is the only angle I can work with. However, for triangles, I mean, any angle really could exist, but we're using inverse sine to get our answer. So the idea is, what's the relationship between these two angles? The relationship between these two angles is that the two of them added together give me 180, take me all the way around. They're supplementary angles. So if I redraw this picture and I say, okay, using the inverse sine just to do a basic calculation, I came up with an answer of 54 degrees. Right? Let me go back and check, is that right? Yeah, 54 degrees. Here. And the inverse sine said, basically I took the inverse sine of something, whatever that whole thing was. You know, what I'm talking about here is I took the inverse sine of this, and I got 54 degrees. Okay. But I can take the inverse sine of, you know, well, I can take the, you know, the idea is, let me back it up for a second. I took the inverse sine of something and I got 54 degrees, which is the same thing as saying the sine of 54 degrees equals this something here. But I could take the sine of another angle and get that same something, because that something that I'm talking about is really the y coordinate here. That's what that something is. And this angle over here has that same exact y coordinate. So the sine of this angle should be the same as the sine of this angle, but however, the inverse sine only gives me one of them, but I need two of them because I need the two triangles. How do I figure out what this other angle is? It's the supplement to this. This angle plus this angle should give me 180. So if I want to find the other angle, the second triangle, which would come from the second angle, I got to find the supplement to 54 degrees. So my other angle is 180 minus 54. And I get 126 degrees. So if I go back to the problem, beta B is 54, but B could also be 126 degrees. Now if B has two different values, then that's going to affect C. And if that affects angle C, that affects side C. So since B has two different values, I can get two different triangles. Now the question didn't say find two triangles, the question just said find the two values for B, or just find B itself, and there's two of them. But you then could use that to find the two separate triangles in terms of the remaining pieces. The remaining pieces if B equals this, the remaining pieces if B equals that. The only way you would know to do this, to find B and then also find its supplement, is to know this yields 2 triangles. Okay? If you don't check this, you would never know that there are 2 triangles. You would never know to find this other b value. So the law of sines can get kind of tricky, but if you follow the pattern that I laid out for you, I think it makes it a little bit easier. At least hopefully it does.